Hi everyone, we are on day 2 of lesson 3.1, or I guess part 2 of lesson 3.1 today. Last time we did solving systems of two equations and two variables by graphing. Today in this video we are going to talk about solving systems of two equations and two variables using substitution. Okay, so it says investors try to control the level of risk in their portfolios by diversifying their investments. You can solve some investment problems by writing and solving systems of equations. One algebraic method for solving a system of linear equations is called substitution. Oh, and we are on page 33. If you are not there yet, page 33. Okay. All right. So taking a look at this math term over here, it says in the substitution method, you solve one equation for one variable in terms of another. Then substitute that expression into the other equation to form a new equation with only one variable. Solve that equation, substitute the solution into one of the two original equations to find the value of the other variable. Yikes, kind of confusing, right? But basically what that means is your first step is you want to solve for either x or y most of the time, or one of the variables, okay? So let's look at this first example, example A, and it says during 1 year, Sarah invested $5,000 into two separate funds, one earning 2% and another earning 5% annual interest. The interest Sarah earned was $205. How much money did she invest in each fund? Okay, so step one, and this is a word problem. So it says let x equal money in the first fund and y equal money in the second fund. Write one equation to represent the amount of money invested and write another equation to represent the interest earned. Okay, so first thing, the amount of money invested. Well, we don't know how much she put in each account. That's what we're trying to figure out. But we know X is going to represent money in the first fund and Y money in the second fund. So X plus Y is going to equal how much money we know she invested total, which was $5,000. So that's what it says there. The money invested is $5,000. So that would be your equation here. X plus Y equals 5,000. Okay. Then the other one has to do with the interest rates and how much she earns in interest. So that's right here. It says 0.02x because we know in the first fund she gets 2% interest, and we use percentages as a decimal. And then in the second fund, she gets 5%, so that's 0.05y. And then we also know that she earned, so here, let me underline, 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 and she earned $205 in interest. So since all three of those parts are talking about the interest, those are going to go in an equation together. Okay, cool. All right, so now we're going to actually solve this using substitution. And the first thing, like I was saying, that you want to do is get one equation, get one of the variables by itself. So that's what they did here. What they did they chose the first equation, again, simply because it was easier, okay? And they just subtracted x over to get y by itself. So now they know that y equals 5,000 minus x, okay? And it's in a different color here, but what they did is they took that 5,000 minus x and they plugged that in for y in the other equation, okay? And so they substituted it in for y because they know that that's what y equals. And now they only have one variable in this equation, and they're both x's. So as soon as you only have that one variable, then you can solve. So they would have to distribute and combine like terms, which they did here, and get x by itself to solve, and x equals 1,500. So now we know that Sarah invested $1,500 into the first fund because remember, X represented money in the first fund. Okay, but we still need to solve for Y to figure out how much was in the second fund. So then you're going to plug in that x value, which they did here, into the first equation, again, because it's easier. So 1,500 plus y equals 5,000, and they just subtract the 1,500 over to get y equals 3,500. So your final solution is that Sarah invested 1,500 in the first fund and 3,500 in the second fund. Okay. And this little math tip here, which is a great tip, is to check your answer by substituting the solution, 1,500 for x, 3,500 for y, back into the original equation, the second one. Okay. All right, cool. Let's go ahead and try one more example together. And I'm just going to choose B. Okay. So we have the system x plus 2y equals 14 and 2y equals x minus 10. Okay. Now, what you want to do first, as we mentioned before, is you want to get one variable by itself in one of the equations. Usually, I like to go the easiest route. Okay, so I try to pick a variable that already has a lead coefficient of 1 because that's easiest. Then we don't have to do any division. Okay, so I'm going to try to get x by itself in this first equation. Okay, so x plus 2y equals 14. If I want x by itself, I'm just going to subtract over 2y. Okay, when I do that, I know x equals negative 2y plus 14. Okay, cool. So now I know that x equals this. So I'm going to plug that in for x in this equation here. Okay, so I have 2y equals a negative 2y plus 14. All right, and I just plugged in what I had there, but then I also need to bring down this minus 10. Okay, now I am solving this, so 14 minus 10 is 4. I just combine those like terms. And then I'm going to get all the y's to one side. Extend my page a little. So I'm going to add this 2y over. And I'm going to be left with 4y equals 4. And I need to divide by 4 on both sides. And I get y equals 1. Okay, cool. But I'm not done. I need to plug that y value back in to see what x equals. Okay, so I'm going to plug that y value back in here to the first equation. So x plus 2 times y we know is 1 equals 14. 2 times 1 is 2. And to get x by itself, I need to subtract over the 2. So I get x equals 12. So now if I were to write this as an ordered pair, I would write it as x comma y, so 12 comma 1. Okay. And like it mentioned in the other problems here, if I want to plug back in and check my work, I'm going to plug in to the other equation. So to the second equation, 2y equals x minus 10. I'm going to plug in and check my work. So I'm going to plug in 12 for x and 1 for y. And 2 times 1 is 2. 12 minus 10 is 2. So I know, yep, that is true. Okay. So this would be your final answer, the ordered pair 12 comma 1. Okay. Again, if you did that a different way, where let's say you wanted to start out by solving for x in this equation first, and you added the 10 over, that's fine. That works too. Okay. It should work out even if you solved for a different variable first, it should work out the same way. Okay. We'll do some more practice with substitution tomorrow in class. If you have any questions, please let me know. Have a good one. Bye-bye.